Hi, so I'm going to go through part C of question 1 on Math 2018. And for this question, they give us the equations of two quadratics, and they want to know some conditions for when these quadratics have exactly two intersections. Okay, so let's think what our quadratic would have to look like to have exactly two intersections. Alright, so here is one quadratic, and for the second one to intersect in exactly two places, then it's going to have to go through it something like this, right? So one of these quadratics would have to be the blue one, and the other would have to be the green one. So first, let's say if this was the blue one and this one was the green one. Now we have that C is the y-intercept of this quadratic, so we have this value as C, and similarly D is the y-intercept of this quadratic, so we have that D is down here. So we can see that if this is ax squared plus c and this one is bx squared plus d, then we must have d being less than c. Now we also have that this a is just stretching our quadratic in the y direction, so the greater a is, the steeper as well the sides of the quadratic will be. And similarly for b with this quadratic. Or you can also think of it in terms of the derivatives. So the greater a and b are, then the steeper the gradient as x increases. And now we see that the gradient of the b quadratic is steeper than that of the a quadratic. And so in this case, we also have that b is greater than a. So that was case 1, where this blue quadratic is this first one that we were given, and the green one is the second one. Let's now look at case 2, where the green one is the first one and the blue one is the second one. Well, now then everything's just exactly swapped around, right? So we have D being greater than C, and also now A is going to be greater than B. So we can also have D greater than C and A greater than B for there to be two intersections. Now, we can have either of these, right? We can have either D less than C and B greater than A, or both D greater than C and A greater than B. And in either case, our conditions involve all of A, B, C, and D, right? So we can immediately rule out all of these options where not all of them are involved. As for option B, well, case 2 doesn't satisfy it. Because if we divide this by B and this one by D, then we see that A over B is greater than 1, C over D is less than 1, so A over B would be greater than C over D, so this condition doesn't work. So we can also rule that one out. And to see that it is in fact E, we can rewrite our conditions by just taking C from these inequalities and taking B from the bottom one. So either we have both D minus C and A minus B are less than 0, or D minus C and A minus B are greater than 0. So D minus C multiplied by A minus B would give you both of these conditions. So again, the answer is E.